This is Unit 9, Refrigerant Oil and Chemistry, Management, Recovery, Recycling, Reclamation, and Retrofitting. Refrigerants and the environment. Chemicals are reaching the Earth's atmosphere. Some of the chemicals are refrigerants. Refrigerants are stable if contained. Refrigerants are pollutants when released into the atmosphere. Ozone depletion. Ozone is found both in the stratospheric region of the Earth, 7 to 30 miles above the Earth, and the tropospheric region, ground level to 7 miles up. The stratospheric ozone is good ozone and shields the Earth from excessive amounts of sun's ultraviolet rays. The tropospheric ozone is considered a pollutant such as smog. If you look at this picture here, basically it shows the atmospheric regions of our Earth. Basically, stratospheric region exists 7 to 30 miles up. The area that we are located in is the tropospheric region, basically from ground zero up to 7 miles up. And then the ionosphere is 30 to 300 miles up. And then, of course, we have space after that. Effects of ozone depletion. Depletion of ozone shield can cause an increase in skin cancer and cataracts in humans and animals. This is very apparent. I know people all the time that are getting skin cancer diagnosis now, especially. Also, you can have an adverse effect on your plants and marine life. An ozone molecule is made up of 3 oxygen atoms. Chlorine destroys the ozone molecules. 1 chlorine atom can destroy up to 100,000 ozone molecules. Ozone depletion potential, ODP. The higher the ODP, the more damaging the chemical is to the ozone layer in the stratospheric region. Ultraviolet rays break off the chlorine atom of a CFC module. The chlorine atom attaches itself to the ozone and forms a chlorine monoxide molecule and is an oxygen molecule. In this illustration here, we show an ozone molecule O3 under letter A and a standard oxygen molecule in letter B. The ozone molecule O3 and B, again, the standard oxygen molecule. Breaking up an ozone molecule. UV radiation, if you look on the first portion right up here, basically you have ozone 3, O3, the breaking up of an ozone molecule by ultraviolet radiation. Then you have the oxygen atom, standard oxygen molecule located down here. And we also are very concerned, especially now, about global warming. We now call it GWP, global warming potential, or climate change, whatever. Refrigerant gases prevent the Earth's infrared radiation from escaping from the lower atmosphere. It is also called the greenhouse effect. HFC 134A has 0 ozone depletion potential but contributes to global warming. The total equivalent warming impact, that's letter TEWI, measures the global warming effects of refrigerants. Refrigerants. Most refrigerants are made up of methane, ethane molecules. Removing hydrogen atoms and adding halogens such as chlorine or fluorine creates a halogenated refrigerant, including CFCs, which of course are no longer made. They went out in 1996. HCFCs, hydrochlorofluorocarbons, which are now gone as of 2020. HFCs, which are hydrofluorocarbons, which are going to be on their way out. HCs, hydrocarbons, and HFO, hydrofluoroolefins. Molecules and refrigerants. If you look at letter A, you've got the H is represented the hydrogen atom, and then of course you got the carbon atom, which is the letter C in the center. Then you move over here to the letter B. Ethane molecules. Both molecules are hydrocarbons. CFC refrigerants contain chlorine, fluorine, and carbon. CFCs are the most damaging to the stratospheric region ozone because the molecules are destroyed before they reach the stratospheric region. On July 1st, 1992, it became illegal to intentionally vent CFC refrigerants. CFCs were phased out of production at the end of 1995, began January 1st, 1996, are no longer available. There are very extreme limited amounts of CFCs still in use around the globe, including the United States. HCFC refrigerants contain hydrogen, chlorine, fluorine, and carbon. The HCFC group is scheduled for total phase out by the year 2030, and that actually got accelerated up to 2020. R22 was no longer used in new equipment after 2010, total phase out in 2020. July 1st, 1992, it became illegal to intentionally vent HCFC refrigerants. HFC refrigerants contain hydrogen, fluorine, and carbon. Do not contain chlorine, will not deplete the Earth's protective ozone layer, but they do have a potential to contribute to global warming. November 15, 1995, it became illegal to intentionally vent HFCs. R12 systems can be retrofitted to operate with R134A. The pressure-temperature relationship is very similar. As an example, HFO refrigerants contain hydrogen, fluorine, and carbon. Fourth generation refrigerants, they're in widespread use now. They're environmentally friendly, cost-effective, energy efficient. HFO 1234YF and HFO 1234ZE are examples of HFO refrigerants, which you'll see in automotive, air conditioning, and other appliances. Low global warming potentials is the what makes these refrigerants acceptable for use. HC refrigerants contain no fluorine or chlorine. They contain only hydrogen and carbon. They have zero ozone depletion rating. They still contribute to global warming. Used in limited conditions with limited charge amounts in the USA because they are highly flammable. Common HC refrigerants include methane, ethane, propane, and butane. Now, if you'll look at the bottom, those are all considered flammable chemicals, and we'll talk more about this later. Flammable refrigerant applications are now allowed in certain circumstances. The EPA's SNAP program has approved only the following refrigerants at this point. R600 alpha, which is isobutane, R290, which is propane, R170, which is ethane, HFC 132, difluoromethane, and then R414 alpha HC blend. I have not personally used any of these at this point. Nameplates and labels. Nameplate or serial label indicates what the HC refrigerant can be used in the system and compressor. Other sections with warning labels: evaporator sections, compressors or condensing unit compartment, exterior of the refrigerator, exposed tubing. Service access and tube painting. Refrigerant piping through which the refrigerator or freezer is serviced must be colored red. This is PMS with number 185. The red piping must extend at least 1 inch or 2.45 centimeters from the compressor, 1 inch on each side of the process tubes or service ports. This is an identification method to identify these new refrigerants. Compressor terminal venting occurs when the terminal pins blows out of the ceramic fuse type terminal. Allows pressurized refrigerant and oil spray to escape into the atmosphere. This spray can become ignited by electrical sparking and cause flash fires, severe injury, and even death. Terminal pins can also become damaged from misuse from a physical jolt. Boiling points and safety classifications. Hydrocarbon-based refrigerants have a low boiling point. Exposing the skin to liquid refrigerants can cause severe frostbite. Exposure to eyes can cause blindness. Safety precautions must be followed in regard to handling, transporting, and storing refrigerants and/or cylinders. Refrigerant numbering. Refer to the refrigerants by the number derived from their chemical composition. These are developed by the DuPont company. As an example, HCFC 123. This is the chemical composition here. Dichlorotrifluoroethane. Number of fluorine atoms is 3. Number of hydrogen atoms is +1 is 2. Number of carbon atoms -1. So you basically have the chemical composition right here. So this is how they come up with these numbers for refrigerants. Refrigerant blends. They can contain as many as 5 refrigerants. Azeotropic mixtures are blended refrigerants of 2 or more liquids. Near azeotropic mixtures can separate. When leaking from a system, they will leak out at different rates, and this is referred to as fractionization. And the problem with this is when you have a system that develops a leak, the refrigerant leaks out at different rates, and what's left inside the system is no longer the same chemical composition when the refrigerant was first installed. And for that reason alone, fractionization takes place and the refrigerant has to be recovered and replaced with a new batch. Azeotropic blends have a greater temperature glide and fractionation than near azeotropic blends. The R number for refrigerant or for the blends. 400 series blends, near azeotropic blends. The 500 number series blends, azeotropic blends. Blends can also be named by the percentage of each refrigerant that make up the blend, have capital letters at the end. This is identification purposes only. Popular refrigerants and their compatible oils. HFC 134 alpha is an alternative refrigerant of choice to replace CFC 22, which is in widespread use. HFC refrigerants make up 134A insoluble. Thus, they are incompatible with mineral oils used on many applications. So from a retrofitting standpoint, if you have an old system, you're putting in R134A, you have to change the compressor oil. R134A systems must employ synthetic polyol ester, POE, or polyalkylene glycol, PAG lubricants. The PAG lubricants you will find in automotive technology, whereas the POE you're going to find in residential and commercial compressors. Refrigerant oils and their applications. Almost as many new oils are on the market as there are refrigerants. Let the compressor manufacturer compressor manufacturers specify what oils be used in application. I can tell you pretty much 95% of everything you're going to install in refrigeration air conditioning today contains POE oil. Oil groups are divided into naphthalate oils, which are most often used with refrigeration air conditioning applications. Popular synthetic oils are alkylate benzenes, which work with HCFC refrigerants. Glycols, which are PAGs, these are strictly automotive. And esters, which are used in HFC refrigerants, including polyesters oil. So basically, all thing you need to remember are the PAGs. They're used in automotive applications. Alkylate benzenes are pretty much it's still available, but typically all compressors today utilize the POE oil. Regulations. The Montreal Protocol Act, signed by more than 30 countries, limits the use and production of CFC refrigerants. Sets a date for phase-out refrigerants that damage the ozone layer. The United States Clean Air Act of 1990 regulates the use, disposal of CFC, HCFCs, and they're enforced by the EPA. Recover, recycle, or reclaim. You need to know the difference between the three of these. Recovery removes refrigerant in any condition from a system and stores an external container. Typically, when you go out on a job, whether it's refrigeration, air conditioning, you're going to pull out the charge of a system. As an example, you're going to do a change out from R22 system to a 410A system, which I do all the time. I have to remove the R22 that is in the existing old system, store it in a bottle. When the bottle reaches its 80% capacity, then I take and ship that bottle off. In some cases, I get reimbursement for it. Other cases, I get a basically just a bottle exchange with an empty one, but basically this refrigerant goes out and gets reclaimed. Recycling talks about cleaning up the refrigerant by oil separation and single or multiple passes through devices. There's machinery available to do this on the job site. Typically, as a service tech, you will not be involved with this process because the equipment's quite expensive and it requires a lot of filtration in order to achieve this recycling method. Reclaiming processes refrigerant to new specifications, which I believe is ARI 700. Methods of recovery. Passive recovery or system-dependent recovery. This is the term that is used when you're recovering. Utilizes internal pressure of the system or the system's compressor to aid in refrigerant recovery process. So as an example, you could utilize a working compressor to push the refrigerant out of a system into a bottle, or in the case of a small appliance, a whirlpool bag. Active recovery, this is the type of recovery you will be involved with continuously on air conditioning refrigeration systems. Utilizes a self-contained recovery unit to remove refrigerant from a sealed system. Technician certification. November 1995 required all technicians to be certified under Section 608 of the Clean Air Act. Type 1 refers to certification of small appliances such as refrigerators, ice machines. Typically, they have a small amount of refrigerant in these type of appliances. Type 2 certification, medium, high, and very high pressure applications. This would be primarily air conditioning units such as chillers, commercial, industrial, and residential equipment containing larger amounts of refrigerant. Type 3 certification is your low pressure appliance such as a centrifugal compressor. And of course, if you pass the core exam plus type 1, type 2, type 3, you can earn a universal certification. And this is the one that you should always strive for when you are taking an exam, to get a universal. Universal allows you to work on anything and everything. Mechanical recovery systems methods. The fastest method takes it out in liquid state. You want to recover quickly, take it out in a liquid state. The problem is active recovery machines are somewhat limited in pumping out liquid. They are more or less designed to pump out a vapor liquid mixture depending on the manufacturer. The slowest method is remove it in a vapor phase. If you like to sit around and drink lots of coffee, recover refrigerant and vapor, you'll be there for 1 or 2 hours, guaranteed. Recovery cylinders are approved by the Department of Transportation. They are stamped with a DOT number. Recovery cylinders should never be filled more than 80% of their liquid capacity. Mechanical recovery system tips. All refrigerants to be recharged in a system should be tested for acids. Cross-contamination should be avoided. Recovery cylinders should be evacuated to at least 1,000 microns before recovery. Weigh the cylinder before and after the recovery process to determine how much refrigerant was recovered from that system. Always follow the manufacturer's instructions when using recovery equipment. Recovering refrigerant from small appliances, defined as a system manufactured, charged, and hermetically sealed with 5 pounds or less of refrigerant. Recovery through the use of low-loss fittings, Schrader valves, piercing valves. Refrigerant bags are available for recovery of refrigerant from small appliances such as required by the EPA. Now, they are commonly referred to as a whirlpool bag. I will personally be honest with you, I've never seen one. I've seen pictures of them. This is questions that you'll find on your EPA exam under Type 1. Reclaiming refrigerant returns the refrigerant. You take and return the refrigerant to a reclamation center. Reclaim companies only accept cylinders of 100 pounds and larger. Only DOT approved cylinders with the proper labels can be used. Refrigerant in the reclaimed cylinders must be of one type. Mixed refrigerants cannot be separated and are usually destroyed by incineration, and the company that turns these bottles in is responsible for the payment of those services. Refrigerant retrofitting, HCFC 22R22. New systems are manufactured now with our HFC 410A. Best retrofit for R22 system depends on several key factors: air conditioning versus refrigeration temperatures, application of the equipment, and the size of the equipment. Excuse me. General retrofitting considerations. Factors to consider when retrofitting: compatibility of the plastic and elastometers to the system, lubrication selection, system performance related issues. Most refrigerant replacements are not done on a pound for pound basis. Warranties may be impacted if the system is retrofitted. I don't think you're going to find this an issue because pretty much all the air conditioning equipment's been 410A for a long time. If you're going to try to convert an R22 system to 410A, don't waste your time. The reason why I say that, most of the components of an old R22 system will not accept 410A. There are some exceptions. Let's say that you have an air conditioning system which was installed 10 or 15 years ago, and let's just say that the evaporator coil was rated for 410A. If the metering device is also rated for 410A as far as the pressure drop through the piston or the TXV valve is in place, then yes, you could put in a new outdoor unit utilizing R410A versus the R22 units, which are no longer available. But now here's what the thing we got to be very careful about. Energy efficiencies will not match the coil rating versus the brand new unit outside. So it is always best when you're changing out a system to change the coil and the condensing unit as well as the refrigerant piping, because typically it's usually too small. General retrofitting procedure. First of one and two, identify and resolve any existing conditions that may adversely affect the system operation. Obtain baseline data for the present system. Remove the existing compressor oil. This is a lot of work, especially in hermetic compressors. If required, to the required level required by the manufacturer. Recover existing refrigerant. Replace the system filter dryers. Pressurize the system with an inert gas such as nitrogen. Check for leaks. Evacuate the system, then wait. Charge the system according to the manufacturer's guidelines. Adjust the thermostatic expansion angle setting and other refrigerant flow controls. Record the system operating parameters. Label the system for future service personnel. Now this last one, I have a real beef with a lot of service techs out there today because they use R22 alternative refrigerants and they do not bother to label the equipment that an R22 unit has been retrofitted with this chemical. This is something that must be done because here's the deal. If you have a system that contains R22 as low in refrigerant and you do not have R22 in there, but you have R407C as a blended refrigerant on the truck, the temptation is to take that 407C and add it to the R22 that's still remaining in the unit in order to get the charge level up and get the pressure temperatures to work. The problem is now you have a chemical that doesn't exist on the refrigerant pressure temperature charts. You are going to have an impossible time trying to predict the temperature and pressure approach levels of this mixture of refrigerants. And then the other problem is this. When you go to change out the system, now you have mixed refrigerants. These refrigerants can be, in some cases, separated out, but it's expensive. You've created a can of worms. And what am I saying? I'm just saying, do not mix refrigerants. If you have R22 system, you do not have R22 virgin state on your truck in order to take it, fix the system charge, and pull out the remaining R22 and employ the retrofit guidelines and utilize a substitute refrigerant. Word of caution here. Some of the so-called R22 blends that are out there, you will see reductions in heat transfer capacity in the evaporator coil. R22 has certain characteristics. R407C, as an example, has certain characteristics. New 22 has certain characteristics. Please be aware of all the ramifications in order to achieve a 40-degree coil on an air conditioning application.